Namaskar. Welcome to the unit on chilling and freezing of fish. The main objective of chilling is to cool the fish as quickly as possible because delayed chilling drastically reduces the quality of fish. The chilling of fish is a process by which the temperature of fish is reduced close to 0 degrees Celsius but not below the freezing point of water. Chilling delays both biochemical and bacteriological spoilage in fish and prolongs the storage life of fish, but the deteriorative reactions are not completely stopped. The quality of chilled fish depends on the initial quality of fish, duration of chilling and the storage temperature. Lower the temperature, slower is the enzyme and bacterial activity, and longer is the storage life of fish. Packaging of fish under appropriate proportions of different gases, that is modified atmosphere, such as carbon dioxide, nitrogen and oxygen, also helps extension of shelf life of product during storage. The following aspects will be studied in this episode: properties of ice, chilling of fish, freezing of fish and modified atmosphere packaging of fish. Now, firstly coming to properties of ice. Refrigerants are liquids which have low boiling point and high latent heat of evaporation. Ice is the cheapest refrigerant. At normal atmospheric pressure, pure water changes from liquid to a solid at 0 degrees Celsius and ice will melt at the same temperature. For water to change to ice, heat energy, that is latent heat of fusion, must be removed. The latent heat of fusion for water is 80 calories per gram and the specific heat of water is 1 calorie per gram. When ice melts, it absorbs large quantities of energy. When ice comes in contact with fish, it will absorb heat from fish and the temperature of fish drops to 0 degrees Celsius, which is ideal for maintaining quality fish. The advantages of ice are: ice has high heat absorption capacity, that is 80 times higher than same quantity of water. Melting of ice helps to wash away bacteria and contaminants. Ice keeps the fish wet and moist. The ice melt water in contact with fish is a good conductor and facilitates cooling. Ice made from potable water is non-toxic. Ice can be transported from place to place and can be considered as portable refrigeration. Ice is relatively cheap compared with other means of preservation. Types and production of ice. Ice is produced as block ice and small ice. Block ice is made of different sizes from 12 to 150 kg block. Based on shape, small ice are flake, tube and platen nugget ice. Each type has advantages and disadvantages. In India, block ice is crushed and used widely. Ice manufacture requires suitable site, supply of water and electricity. The mechanical refrigeration system consists of an evaporator. In this system, the liquid refrigerant passes and changes into gas whose latent heat is drawn from evaporator. The refrigerant gas then passes to a compressor which converts it to a high pressure, high temperature gas. The hot pressurized gas is liquefied by cooling in the condenser. From the condenser, the liquid passes through an expansion valve back to the evaporator. Requirement of ice for chilling of fish. The quantity of ice required to chill a given quantity of fish can be calculated by knowing the following, that is temperature change, fish temperature, the required temperature, quantity of fish, specific heat of fish and latent heat of fusion of water. Theoretically, 1 part of ice to 3 parts of fish is sufficient, but at the end of the cooling cycle, there would be no ice left to keep the fish cool. Therefore, additional quantity of ice is required. The factors to be considered are ambient temperature, type of container, contact of ice with fish, length of storage and thickness or size of fish. Normally, 1 part of ice to 1 part of fish is used for chilling of fish. Storage life of fish in ice. The length of time that the fish will remain edible in ice depends on many factors such as species, size, method of capture, fat content of fish and feeding and breeding cycle. Generally, fish from warm water, that is tropical, keeps longer than fish from temperate water. Non-fatty fish keep longer than fatty fish and freshwater fish keeps longer than marine fish. The storage life fish stored in ice is presented in Table 1. Table 1, storage life of fish stored in ice. First column is the species, second column types and third column length of storage in days. Marine, temperate 10 to 15, marine, tropical 15 to 20, freshwater, temperate 12 to 20, freshwater tropical 15 to 20. Note, tropical fish can be stored in ice for longer fish than temperate fish. Similarly, freshwater fish has longer storage life than marine fish. Results of this table reveal that temperate marine fish can be stored in ice for 10 to 15 days while tropical fish for 15 to 20 days. Similarly, temperate freshwater fish can be stored in ice for 12 to 20 days while tropical freshwater fish for 15 to 20 days. Now the second part, that is chilling of fish. Chilling is an effective way to reduce spoilage of fish if it is done quickly. Fish should be chilled and handled hygienically throughout the distribution chain. Ice is an ideal cooling medium and widely used at the point of harvest to control the loss of freshness. Nowadays, the use of ice on board the fishing vessel is a common practice in many commercial fisheries where voyages are of several days' duration. The boxing method of icing of fish is the best as the handling of fish is minimal and fish can be packed according to size species. Plastic boxes are commonly used. They are strong and robust, easy to clean and filled boxes can be stacked one above the other so that the weight of the top box is taken by the box below without pressing the fish. When empty, the boxes can be nested to save the storage space. The correct and incorrect way of packing fish with ice in boxes is presented in Figure 1. The delay in icing has profound effect on storage life of fish. The rate of spoilage of fish is temperature dependent. For every 5 degrees Celsius increase in temperature, the storage life in ice is reduced by half. Effect of storage temperature on shelf life of fish is presented in Table 2. Table 2, effect of storage temperature on shelf life of fish. First column is the storage temperature, second column relative rate of spoilage and the third column storage life. 0 degrees Celsius 1, 14 days, 5 degrees Celsius 2, 7 days, 10 degrees Celsius 4, 3.5 days, 20 degrees Celsius 8, 18 hours, 25 degrees Celsius 12, 9 hours, 30 degrees Celsius 16, 4 hours. Note, relative rate of spoilage of fish stored at 0 degrees Celsius increases from 1 to 16 when stored at 30 degrees Celsius with the concomitant decrease in shelf life of fish from 14 days to only 4 hours. Relative rate of spoilage of fish stored at 0 degrees Celsius increases from 1 to 16 when stored at 30 degrees Celsius with the concomitant decrease in shelf life of fish from 14 days to only 4 hours. Super chilling of fish. Reducing the temperature of fish slightly below 0 degrees Celsius, that is 0 to -3 degrees Celsius, is referred to as super chilling or partial freezing of fish. Super chilling is obtained by using refrigerated seawater and chilled seawater. Chilled seawater is more cost effective than refrigerated seawater. It is an excellent method for preservation of small pelagic fish species such as sardines and mackerels. Shelf life of fish under super chilling conditions is presented in Table 3. Table 3. Shelf life of fish under super chilling conditions. First column is the water temperature, second column amount of water frozen, and the third column shelf life of fish under super chilling. Minus 1 degree Celsius 15% 17 days, minus 2 degrees Celsius 55% 22 days, minus 3 degrees Celsius 70% 29 days. Note, under super chilling conditions, as the water temperature decreases, the amount of frozen water increases with an increase in shelf life of fish. Under super chilling conditions, as the water temperature decreases, the amount of frozen water increases with an increase in shelf life of fish. Under super chilling conditions, the amount of frozen water varies from 15% at minus 1 degree Celsius, 55% at minus 2 degrees Celsius, and 70% at minus 3 degrees Celsius, with similar increase in shelf life of fish from 17 days, 22 days and 29 days respectively. The advantages of super chilling are rapid cooling, less damage, less labor and less ice. The disadvantages of super chilling are salt uptake by the fish, growth of anaerobes. Next is freezing of fish. Freezing is an excellent method of preservation for seafoods. Freezing is a process of removing heat so that the water in fish is converted into ice. Freezing is superior to other methods of preservation due to lowering of temperature, retards or stops most reactions including bacterial activity. Water in ice form is not available for bacteria for their biological functions and hence their growth is prevented, and there is complete immobilization of the system, thereby reducing spread of organisms by convection. Fish preserved by freezing retains its original quality attributes without significant modification. Proper method of freezing and storage at right temperature gives a product resemblance to fresh fish so that the consumer will be unable to distinguish between a frozen and a fresh fish. If freezing is not proper and the product is stored for a long time, the product exhibits number of defects such as changes in texture, that is changes in proteins, tough, coarse or rubbery or spongy, changes in odor and flavor, that is changes in lipids, oxidation or rancidity, losses in weight, that is 15 to 20% drip loss or fluid loss or loss of WHC, changes in color, that is fading of pigments and dehydration or freezer burn. These changes result into reduction of fish quality. Therefore, it is important to minimize these changes which are unavoidable. There are certain normal changes during freezing of fish which are unavoidable. They are mentioned below. Phase change. Fresh fish contains about 80% water. Pure water freezes at 0 degrees Celsius. Since the fish flesh contains dissolved salts, the freezing temperature varies usually between 1 to minus 2 degrees Celsius. At minus 5 degrees Celsius, it would appear that all the water in fish is frozen, but nearly 20% of water is unfrozen. At minus 20 to minus 30%, nearly 85 to 90% of water in fish is frozen and 10 to 15% is still unfrozen. Expansion in volume. Pure water expands by 9%. This results in possible damage in texture. Concentration of solutes. As the temperature is lowered and cellular water is frozen, the mineral salts and soluble organic substances become concentrated in the remaining unfrozen state. This increase in cellular condition causes protein denaturation. Rate of freezing. The speed of freezing has a major influence on ice crystal formation. Slow freezing produces large ice crystal outside the cell walls and damages the cell wall, that is extracellular. Quick freezing produces small ice crystals inside the cell walls, that is intracellular, which causes minimum damage to cell walls. Slow bacterial growth and enzyme activity. Mechanical stress causes freeze damage. Freezing curve given in figure 2 is a temperature plotted against time defining different stages of fish freezing. The different stages of freezing are: stage 1, temperature of fish falls rapidly to 0 degrees Celsius. Stage 2, temperature of fish remains fairly constant, that is -1 degree Celsius, and slowly moves to -5 degrees Celsius when about 80% of water is frozen due to removal of latent heat. Stage 3, temperature drops rapidly due to removal of sensible heat as the water remains frozen. The amount of heat removed from 1 kg fish at 25 degrees Celsius is: from 25 degrees Celsius to 0 degrees Celsius, that is stage 1, 1 into 26 into 4.2 kilojoules, which is equal to 109.2 kilojoules. From 0 degrees Celsius to -1 degree Celsius, that is stage 2, 1 into 334.7 kilojoules, which is 334.7 kilojoules. From -1 degree Celsius to -30 degrees Celsius, that is stage 3, 1 into 29 into 2.1, that is specific heat, which is equal to 60.9 kilojoules. The total would be 109.2 plus 334.7 plus 60.9, which is equal to 504.8 kilojoules. During freezing, 65% of heat extracted in stage 2, that is thermal arrest time TAT, or critical temperature zone, refers to the time required for stage 2. For the production of good quality frozen fish, the TAT should be as short as possible. Next is quick freezing. If the time required to lower fish temperature from 0 degrees Celsius to -5 degrees Celsius is 2 hours or less, it is referred to as quick freezing. In quick freezing, the fish is frozen at -20 degrees Celsius and stored at -30 degrees Celsius. If the temperature is not brought down to -20 degrees Celsius, the salt concentration increases, autolytic spoilage. After freezing, the fish should be unloaded and stored immediately. If it is left in freezer for too long, it causes freezer burn. Freezing is faster near the surface and slower in the center of fish. Table 4 lists the rate of freezing in terms of thickness of fish frozen per hour in different methods of freezing. Table 4, rate freezing in terms of thickness of fish frozen per hour in different methods of freezing. First column is the freezing method and second is the rate of freezing millimeters per hour. Slow freezing 2, quick freezing 5 to 30, rapid freezing 50 to 100, ultra rapid freezing 100 to 1000 millimeters per hour. Note, in terms of thickness of fish, the rate of freezing increases with rate of freezing, that is from slow freezing to ultra rapid freezing. Based on thickness of fish, the rate of freezing is 2 millimeter per hour under slow freezing conditions, 5 to 30 millimeter per hour under quick freezing, and 50 to 100 millimeters per hour under rapid freezing, and 100 to 1000 millimeter per hour under ultra rapid freezing conditions. Coming to the types of freezers, the 3 types of freezers commonly used are air blast freezers. They are of batch or continuous type, Features of this type of freezers are: the point of entry and exit should be protected with plastic air curtains. The speed of belt can be adjusted according to desired freezing time. Useful for coated products and value added products. Fluidized bed freezer, that is cold air produces a fluidized bed, is suitable for small and uniform sized products. For example, cooked shrimp, green peas, individually quick frozen products. Now next is the contact plate freezer. Plate should be free of ice, good contact with fish. They can be horizontal type, that is shore based generations, and vertical, that is sea based generations. The plate freezers are useful for freezing in block of 2 kg or 5 kg. Immersion freezers. They operate at very low temperature and give rapid freezing rates. There is no dehydration, no drip loss, and provide good quality fish. Next is cryogenic freezing. Freezing is caused by direct contact with the refrigerant. Refrigeration by using salt solution below freezing point can be used for onboard freezing, especially for tuna. Use of liquid nitrogen is most common. Liquid nitrogen boils at -196 degrees Celsius. This method is most useful for individual freezing of fillets and high-priced shrimp. In this method, the fish are sprayed first with liquid nitrogen at about -50 degrees Celsius, and then the temperature is reduced gradually. Cryogenic freezing requires regular supply of liquid nitrogen and its operation cost is high. Other types of low boiling point liquid freezers are R12 dichlordifluoromethane. It is environmentally not friendly and leads to ozone depletion in the atmosphere. Liquefied carbon dioxide. Liquefied carbon dioxide is refrigerated before spraying. Its sublimation point is -79 degrees Celsius. Management of carbon dioxide freezing is more difficult than liquid nitrogen freezing. Factors affecting freezing rate. The rate of freezing fish is influenced by several factors as mentioned below. Airspeed. Faster the airspeed, higher the freezing rate, but high energy cost. The airspeed in blast freezers may vary from 5 to 15 meters per second. Temperature. Higher the temperature, slower is the freezing rate. Normal air temperature lies between -30 degrees Celsius and -40 degrees Celsius. Uniform airflow. It depends on position of fan, design of fan, stacking of the product, and periodical defrosting of evaporator. Other factors: product temperature, thickness, area, size, shape, thermal conductivity, density, latent heat of fusion of food, and surface heat transfer coefficient also influences the rate of freezing fish. Cold storage. After freezing the fish, it is kept at -30 degrees Celsius temperature. Uniform and steady temperature without fluctuation throughout the storage period and proper air circulation are necessary for good keeping quality of fish. Glazing. Serious problems in storage of frozen fish are dehydration, oxidation of fats, color changes, protein denaturation. To maintain quality of the product must be glazed by dipping or spraying chilled water. This gives protection to the product by controlling water loss and oxygen uptake. A thin protective layer may increase the gross weight of fish by 2%, followed by suitable packaging. Shelf life of different kinds of fish under frozen conditions is presented in Table 5. Table 5. Shelf life of different kinds of fish under frozen conditions, storage period in months. The first column is about the type of fish, second is at a temperature range of -18 degrees Celsius, third column is at a temperature of -25 degrees Celsius, and fourth column is at -30 degrees Celsius. Fatty fish 4, 8, 12, lean fish 8, 18, 24, lobster or crab 6, 12, 15, shrimp 6, 12, 12. Note, fish keeps longer freshness at lower frozen temperatures ranging from 4 months at minus 18 degrees Celsius to 24 months at minus 30 degrees Celsius. At the storage temperatures of minus 18 degrees Celsius, minus 25 degrees Celsius and 30 degrees Celsius, fatty fish can be stored for 4, 8 and 12, lean fish for 8, 18 and 24 months, lobster or crab for 6, 12 and 15 months and shrimp for 6, 12 and 12 months respectively. General guidelines for good storage practices are: all products should be labeled clearly, that is the product, type, date of production, code and traceability. Storage plan and temperature records should be maintained. Storage period should be as minimal as possible. Proper glazing and packing improves keeping quality of fish. The product should be kept away from floor, wall and ceiling. Regular defrosting is essential for proper maintenance of storage temperature. Now next, coming to modified atmosphere packaging, that is MAP of fish. Modified atmosphere packaging is an expensive method of fish preservation in combination with chilling. It involves replacement of air in the package with a gas mixture consisting of carbon dioxide, nitrogen and oxygen. The storage life of fish is marginally increased based on proportions of carbon dioxide, nitrogen and oxygen. Normally, the composition of carbon dioxide, nitrogen and oxygen for the lean fish is 40%, 30% and 30% and 60%, 40% and 0% respectively for fatty fish. Higher levels of carbon dioxide leads to discoloration and a cellulose pad is provided to absorb the drip if any. Anaerobic condition leads to risk of Clostridium botulinum and hence strict temperature control in the range of 0 degrees Celsius to 5 degrees Celsius during storage is important. Laminators consisting of 12 micron polyester, 3 micron PVDC and 60 micron polythene is most appropriate for packaging of fish for MAP. The modified atmosphere packaging improves presentation of the product for marketing. Conclusion: chilling and freezing of fish are the most widely used processing methods for preservation of fish. The quality of chilled and frozen fish resembles closely to that of fresh fish if they are properly chilled or frozen. In many cases, the consumer will be unable to distinguish between fresh fish and chilled or frozen fish. The initial quality of fish, hygiene and sanitation, freezing and storage conditions are critical for maintenance of fish quality. Modified atmosphere packaging of fish with appropriate laminate and composition of carbon dioxide, nitrogen and oxygen helps extend keeping quality and marketing of fish and fish products. Thank you.